Today's lesson is on section 6.4, solving compound inequalities. We've been working with inequalities here recently, and now we're going to work on compound inequalities. There's a definition up there. If you're taking notes along with me, I'd like you to jot that down. What's a compound inequality? It just consists of two separate inequalities joined by either the words and or the word or, and I'll explain that in a second. Compound, think of that word. You've probably heard it in English too. We've heard of compound sentences or compound words. That's just when you take two words or two sentences and combine them into one sentence or one word. So compound, same thing here with inequalities. We've dealt with individual inequality problems, and we're just going to combine them by using one of those words. Each one does mean something a little different. Even though all this text here is in black, I'd still like you to write this stuff down, the examples and all the bullet points about each particular case, whether it's and or or. So please do write all those things down that I've kind of circled there for you. So I'm going to pull it away though because I'm going to write some other things, but do write those down in your notes as well with the bullet points. I'm going to talk about each one. So if we join two inequalities with the word and, what does that mean? Well, and for one is inclusive. Okay, so it means we're talking about the solutions for one inequality and the solutions for the other inequality at the same time, kind of like the second one here says. So if I'm talking about x values that fit my example here, x is greater than 0, and then I have another inequality, x is less than 5. If I join them with the word and to make a compound inequality, I need solutions that are greater than 0 and at the same time less than 5. It has to fit both of those criteria at the same time. Again, it's like, and kind of like I have here for like thinking about Venn diagrams, it's the intersection of those two things, okay, where things that overlap or solutions that fit for both of those things individually. So if I try to think of solutions that are greater than 0 and at the same time less than 5, I can think of numbers like 1, 2, 3, 3.5, 2.1, any numbers that are in between 0 and 5 are solutions in this case, because I have to have numbers that fit both of those cases, both those situations when I'm talking about and. When I'm talking about or in this case for a compound inequality means it can either fit one or the other. It can fit either of the two answers or either of the two inequalities. It can fit the first one or the second one here as I've gotten, or again, thinking Venn diagram wise, it could be the union of those two inequalities, where either one, as long as I have a solution that fits one of the inequality, it works for my compound inequality. I have x is less than 2 or x is greater than 6. Again, those are two separate inequalities, but when I join them with the word or, now I'm talking about all the solutions, numbers that fit x is less than 2 or numbers that fit x is greater than 6. So my x values, well, it could be 1, because 1 would fit the first inequality. Could be 0. It could also be 7. It could also be 8. As long as it fits either of the two inequalities, it could be a solution to this compound inequality. Now again, just talking about them, sometimes it's still a little fuzzy or hard to understand the difference between the two and how they work. So that's why sometimes the graphs for inequalities are a big help, because we can visually see what we're talking about. So on the next page here, I'm going to show, well, what does it look like when I'm talking about a compound inequality, whether it's joined with and or whether it's joined with or. So I talked about cases, compound inequalities, where and is the word that joins those two inequalities. And so I'm going to show two separate inequalities here. X is greater than -2 and x is less than 3. What would the graphs of each one of those separately look like? Well, here would be -2. It'd be an open circle on -2, and then I'd also need some numbers around it to show that I'm going to go to numbers that are greater than -2. So in this case, I would be shading to the right. For x is less than 3, this inequality, I'd have an open circle on 3, open circle on 3, and I'd be shading the numbers that are less than 3. So there's those two inequalities, each shaded separately, kind of showed in their section of the number line. Okay. But now if I join them and make a compound inequality, I say that I want solutions that are greater than -2 and less than 3 at the same time. What does this look like? Well, it kind of looks like the combination of those two inequalities. Here would be -2, like I showed, in its section of the number line. Oops, and it's not a filled-in circle. It's going to be an open circle, kind of like I had up there. And I'm going to start shading this way. And then down the road here, here's 0, here's 1, here's 2, here's 3, here's 4. Open circle on 3, and I'm going to shade this way like I have up there. Well, what happens is I need the solutions that are both greater than -2 and less than 3 at the same time. So that ends up being all these numbers in between here. I'm shading in all the possible solutions of that compound inequality, numbers that are greater than 2 and less than 3 at the same time. There is a certain way to write an AND inequality. Not or, but there's a certain way to write the AND inequality, and it looks like this. So this is also something I want you to jot down with this example. -2, this is red, -2 is less than x, which is less than 3. When you're writing one of these compound inequalities, again, these only fit for AND, but I think they do make sense the way they're written out. Look at the graph. It's the same kind of deal here as I like to explain. Here was one of my boundaries, right, -2. My other boundary was over here at 3. Okay. Well, same type of thing in this. -2 is my lowest number, 3 is my highest number. When I write these AND inequalities, that's usually the way I'll write it too. I'll write the lowest number on the left and the highest number on the right. And then all the solutions that I need are in the middle, in this big area. That's what my x values are, so that's why x goes in the middle. So for example, I'll make up kind of a new graph of an AND inequality, and then we'll make one of these AND inequalities. So let's say I have the number -4 here, and then again I could have some other numbers, -3, -2, -1, just making a number line, 1, and then we'll go all the way to 2. So let's say I have -4 and it's a closed circle here, and 2 and it's a closed circle here, and this is an AND case. So let's say those are my boundary numbers, and I'm talking about all the solutions that are greater than or equal to -4 and less than or equal to 2. So that's what my graph would look like. Well, again, if you're going to make one of these, here's your lowest number, here's your highest number, correct? So when students are making these, I tell them we'll start with those numbers. Here's -4. And here's 2, and all my solutions again are in the middle, so x is in the middle. Then I just need to add my inequality signs, and look, taking a peek at that one up there. Some students like to remember that alligator eats the bigger number, right? So which number is the biggest? Well, 2 is the biggest for what I have here, so I'm going to face my inequality signs so that they would eat the biggest number, which is 2. The smallest number is -4, so they all, or both of them, both these signs end up facing to the left. Okay, and here's a little note about these when you're making an AND inequality. There it is, completed. The signs will always face the same way for these if they're going to work correctly. Signs, or the inequalities, I'll just say signs for now. Oops, I'm thinking signs and I put an S there. Signs will always face the same way. For these to work, the lowest number, again, the way I like to arrange them is the lowest number's over here and the highest number's over here. So the lowest number is less than, just kind of going left to right here, is less than whatever the x values are, which has also got to be less than, the biggest number. So that's kind of how the arrangement works, and why that's the way that I tell students to arrange them as well. So the lowest number on the left, the highest number on the right. Put your x in the middle because we're talking about all the x values being in between. And then you have your 2 inequality signs. I know I've spent a little more time on the AND cases because I think those are ones that we'll see more often, and something that I really want us to understand is the AND cases. The OR cases too are also important. I think those maybe are just a little bit easier to understand. Let's take a look at one right here. This OR case, again, it's a compound inequality. It's a combination of these 2 inequalities. So x is greater than 3, greater than or equal to 3. So here's what that inequality would look like by itself. Well, it would be a closed circle on 3, and I would shade to the right. I want all numbers that are greater than 3. Then x is less than -1. Again, just picking out some numbers that are nearby. This would be an open circle, and I'd shade to the left all numbers that are less than -1. So then for the OR case, there's no special way to write it. This is just how you write an OR case. X is greater than or equal to 3, or x is less than -1. Again, making all those numbers that I might see on the number line with it. And now just combining those 2 inequalities. Well, -1 at an open circle, and I shaded to the left because I'm talking about numbers that are less than -1. 3 had a closed circle, and I shaded all the numbers that are greater than 3. There's what the graph looks like for an OR compound inequality. Because remember what I'm saying is, my solutions could be numbers that are less than -1, which are numbers down here. It can also be solutions that are greater than 3, which are up here, and it actually could be equal to 3 in this case. So any of those numbers that are shaded in could work, whether it's -4, -5, -2000, or on the other end, 3, 4, 5, 6, or a billion. Okay, all those numbers work. Anything that fits at least one of the two inequalities is a solution. So OR cases, a little different. Here's what a graph of those might look like. But again, different concept, different idea than an AND case. No other way to write it though. That is just how you write an OR case. The two inequalities with the word OR in the middle. I'm going to go back to AND inequalities for one more second as well, because we can solve these too. OR inequalities you can solve as well. You just kind of solve it like a normal inequality, just each one individually. The AND inequalities, again, because they're written now as just a combination here, where again I've got my lowest number, my highest number, my signs in the middle, and also here's x in the middle too. These we can also solve, and there's just a little trick to them, or at least something to understand. So we're going to solve it just like an equation, or just like any other inequality. I want to get x by itself. Well, in this case, in the very middle, I have x plus 5. So I would subtract 5, and where else do I subtract 5 in this problem? Well, in an AND inequality, it's just I have to subtract it to all three sections of this inequality. So I'm going to subtract it to the first section, the last section, and in the middle to get rid of it here so I can get x by itself and isolate it. So in the middle, I'll just have x. I'll still have my inequalities here less than, in this case, less than or equal to for that one. 6 minus 5 gives me 1. 11 minus 5 gives me 6. So there's me solving an AND inequality just by, again, making sure I subtract 5 to all sections of that inequality. If I'm going to graph it, again, here's 1, here's 2, here's 3. Usually you don't have to list all the numbers, but just to kind of show how this works, I will right now. 1 is my lowest number. It should have an open circle on it, because I'm not saying numbers should be equal to 1. So open circle on 1. 6 numbers could be equal to 6. My solutions could in this case. All x's could be less than or equal to 6. And then I'm talking about, again, x values, the ones in the middle. It says 6 is the greatest number, so I go all the way up to 6 and shade it in. But I want x values that are greater than 1 if I look at the very first part of this inequality. So it's all those numbers that are in between right there. I had a different example, but I'm just going to make one up here right now for number 2, sticking with the AND inequalities to keep working on these. Same thing with this one right here. This one says -5 is less than or equal to 2x plus 3, which is less than 7. Again, if we're going to solve this inequality, and this compound inequality, then again, what I got to do, just like any other problem, I got to isolate x. And here in the middle, I've got a little expression. I got to get those things away from x to isolate it. You see me draw lines when I'm solving equations. You can draw here for the AND inequality too. You just have to draw two different ones. And I just got to remember whatever I do to one section, I got to do it to all three sections in this case. So I'm going to subtract 3 from all three sections. If I subtract 3 in the middle, I'll have 2x. I'm going to raise these just a little bit so I can see my inequalities really good. In the first or the last section there, I'll have 4, and in the first section, I'll have -8. So again, I've just subtracted 3 everywhere to make this work so far. Then I'm going to divide everything by 2, and that should solve this inequality for me. I'll get -4 over here, which is less than or equal to x, which is less than 2. If I'm going to graph it, -4 is my lowest number. 2 is my greatest number. I'm going to have a closed circle on -4 because the x values, -4 can be less than or equal to whatever x is, so it could be equal. And then x has got to be the same. X has got to be bigger than numbers than -4, right? Again, if you think alligator eats the bigger number, if that helps you remember that, okay? So I'm talking about numbers, yeah, shading in this direction, numbers that are bigger if I want x values. All the way up to 2, 2 needs an open circle. And x values are less than 2, though. So I'm going to stop right up there after I put my open circle. There's what my graph of my AND inequality would look like. And I want to go through one more example just to show you one more thing about compound inequalities that makes them just like other inequalities. So So this one again, I'll go through some steps here to solve it and get t by itself in this case. Well, again, I'm going to subtract 2 to all sections of this inequality, so I'm going to get negative 10 over here. I'm going to negative 10 is less than negative 5t, which is less than or equal to positive 5. And so what do I have left in this one? Well, then I just have to divide everything by negative 5. And again, right when I say that, hopefully that kind of rings a bell to you. Because again, for inequalities though, the one thing we have to keep an eye on, they solve just like equations, all the same types of steps. But right here, I divided everything by negative 5. So just like the inequalities we talked about in previous lessons or have talked about in class, when you divide or multiply any inequality by a negative number, I got to switch these signs around for my next step of work. So in the next line I write, I can't have less thans anymore. I got to switch those to greater thans. This has got to be greater than, and this has got to be greater than or equal to. So now I still have t in the middle. I've solved it and got t by itself. That's good. Negative 10 divided by negative 5 gives me 2. And 5 divided by negative 5 gives me negative 1. Now this answer is correct. You can leave it like that. It also is the same thing. It's equal to this, which I'm going to write. And I just write it this way because I like to have the smallest number on the left. Negative 1 is less than or equal to, just kind of flipping the whole thing around over here. T, which is less than 2. So I prefer to see it like that with the smallest number on the left and the biggest number on the right. And then think of my values, because that's usually, again, not always, but that's how you see a number line typically. So I'm going to write it like that. And again, if I'm going to make a graph, here's negative 1, here's 2. I would have a closed circle on negative 1, an open circle on 2, and this is still an and inequality, so I'm going to shade everything in between. Again, I know I focused a little more on the and inequalities, but again, I guess that's something I think we maybe could use a little more practice on than the or cases. And again, you will definitely see both in the homework for this section.